Alright, I want to share a little bit of my experience that I've had with WebSockets, my research into it. I wanted to focus on the JavaScript side, and then it turned out that there was not very much to do on the JavaScript side. So I thought I'd give you a small example of how you can get it done, how you can set up WebSockets with AWS as console. Right, anybody here raise hands if you don't know what WebSockets are? All right. Traditionally, if you want to retrieve data from a web server, you do a polling. Ask the server, is there anything new? Server would respond. Do that every single time it's a HTTP connection. Disadvantage of that is HTTP connections have a little bit of overhead, so there's a bit of latency involved. The concept of WebSockets is that your browser establishes a connection to the server that stays open, and then over that connection, the server can respond to you at any time, send data to your browser. You can ask for information from the server, and the server can even query from the client, ask the client for information to come back. So it gives you a very reactive, very quick to respond UI. So as data changes on the database by one user, you could have an event coming to the browser for everybody to update. The reason we're looking at it is we will be streaming lots of data sets from lots of devices onto a dashboard. And problem is, if you've only got a single server running for that, you can overwhelm a single server if you've got hundreds or thousands of devices. So why, oh, sorry, got ahead of myself. Stateless. Comes down to stateless. We're living in a world where more and more services are becoming microservices, small machines running behind load balancers. So as everybody knows in AWS, you can spin up multiple little instances using Kubernetes or Docker. And every single server, as they come up, they don't know about the client. So every HTTP call that comes in, the client tells it, hey, this is my cookie, this is who I am. All right, give me this data, or save this data, or update data. So the servers do not need to keep track of the clients. This allows you to increase your capacity as you need. So during your peak time, you spin up more servers. As your peak time comes over, you can spin down servers. And that's also where we're moving towards the world of microservices and serverless, where you don't actually have to run an entire server. You can have Amazon or Azure or Google just run a code endpoint for you, which can be hit by clients. And yeah, but WebSockets are not stateless. They get maintained by the server. So every connection that gets opened gets an establishment to a server. So if we look at this case here, for instance, day gets busy, you've got one little server running there. Many clients come up, they all open up their WebSockets, which they'll be maintaining for minutes or hours. You've got a server spinning up in the background. Problem. By the time that server comes online, new client connections might get load balanced over to it, but you still have one server overloaded because it got the initial brunt of all your connections that were opening. Now there are multiple ways that you can get over this. For one is you could periodically close server connections, forcing your clients to re-establish the connection, which will then be load balanced over to whichever server you want. The other disadvantage of server connections staying open, now your peak period is over, most of your clients have left, but you've got one client still connected to an instance, keeping it alive. Not fun. So what does AWS bring? They have recently added WebSocket support to their API gateway. So the beauty of this is that all the long living connections are maintained by the gateway infrastructure, not by your instances living behind it. So you can spin up and shut down AWS services behind the API gateway without worrying about losing your connections to the client. And as your capacity requirements increases, you can scale up. as it decreases, you can scale down again. And yeah, so that is what I want to show you a little bit about. Now, hello world. That's what you always get on the internet when you want to look at implementations of how things work. I wanted to set up a little example of how you could just get beyond that. Because in the default examples, they show you how to handle the connect, how to handle the disconnect, and then how to handle a single message type, which then echoes to all clients, for instance. So we all know the classical chat room example where you have multiple clients, they join certain chat rooms, and messages get moved around based on that. So let's see if I can get something going here. Now, Visual Studio has got, wait, sorry. I see my slideshow is still, so I'm trying to get to my desktop here now. There we go. Let's end the slideshow. Right, Visual Studio has embraced, surprisingly enough, AWS's service as well, even though you'd expect them to try and push you into Azure for every single thing. And one of the huge problems with setting up a decently sized, even if it's just a small hello world example configuration for WebSockets in this case, is you have a lot of moving parts. Actually, I didn't plan to have this file open. I just want to quickly, right, there we go. Amazon uses CloudFormation to allow you to link up multiple different services as a single template. And just for a simple WebSocket Lambda, this is what you end up with. Out of the sample template. Sorry, this is not ideal.
That's ridiculous.
It is ridiculous, but it's surprisingly enough just copy pasting. Because for every single Lambda function you've got to have its permissions, you've got to have how you talk to it, and you've got to have how does the WebSocket offload to it. So the crux of the matter is every WebSocket command you send from your client to AWS's API gateway, it needs to know how to route it, what to do with it, where do we go with it. And that, come back please.
Change the region?
It's not a region thing. Let me just see. So if you've never played with stacks, they're pretty cool. They show you everything that was created based on your requirements. So I'll show you. So I deleted my stack earlier today and reloaded it, and I can't find the WebSocket. Where are you?
Very bottom. No link there.
How useful is that? Apologies, this is not really what I wanted here to show now. Okay, I'll show it in code in the template. Sorry about that.
Sometimes when you hit get started, it goes to the console. I've seen that.
Yes? I know how to create my first API. I've already got one. There it is. There it is. All right. So it's a WebSocket type API, and the important thing that comes down to is your different message types. You can tell it on certain types of fields, do certain work. So in this case, request body root. So in your packet that you send, in the request body, you've got a JSON field, I called it root. If it's a connect or a disconnect type, these are $signs. These are standard AWS implementations. They always exist. And then I created 3 defined ones, join, leave, and send packet. Now the hello worlds will only give you a send message or send or something. So what you tell it to do, when this request happens, call the Lambda proxy and execute our Lambda function, in this case, the one that sends a packet. The beauty of using an IDE type of environment is you don't really have to worry about that. The template abstracts that away from you. So in code, you just do your code, deploy to Lambda, hopefully it just all works. So I just want to show you one of the functions. If you're coming from the C# world, you'll be fairly familiar with the structure of C# file. Every function. Finally! You expose your functions as Lambda functions. AWS just calls it for you. And what I've done is, whenever you join a group, leave a group, updates a DynamoDB. Every time you send a message, it checks who's part of the group you're sending to, notifies them. From that point forward, you connect to the AWS WebSocket using standard WebSocket libraries. So it's not something special. It's not a roll your own like SignalR or some such. So that's why when I came to the world of how can I show this in the JavaScript talk, there's really not much to show. It's JavaScript. So all the magic happens on the AWS's API part, specifically the gateway that manages all the connections for you. So that's where the secret sauce is for them. And yeah, thank you very much. This talk didn't go very well, but I wanted to show you what I found there. Thank you.
Do you have any questions? I have some.
Go for it.
API gateway, as far as I'm aware, is like normally priced on requests.
For
Whereas with
Lambda,
WebSockets, it's like a continuous request. So how does the pricing on API gateway?
you get priced per active connection in the dollars per hundreds of thousands kind of range, so it's not extremely expensive. And then you also get priced for calls that happens. What I did find is when I did the math for a situation we're looking at 10,000 devices sending a frame a second, the thing that kills you is the Lambda function that gets hit for every frame that comes in. So you're better off not using Lambda, but rather putting it into a Kinesis stream or doing other kinds of calls on there. But yes, there is a per message cost as well.
If you're using, say you're using EC2, not Lambda.
Yes.
And you've got API gateway is, you've got EC2 instances coming up and down as you scale, and connections like getting, API gateways holding the connections.
Yes.
And each message gets sent to a certain EC2 instance. What about like the whole point of WebSockets is the message is going back the other one. So how do you address a client when you don't have a persistent connection to that client on your instance?
You can send a if you know the client's identifiers, which you should because you've got it in a stored a shared storage area. You can send a Lambda function, can make a call to them. I haven't checked explicitly, but I think you would be able to use the libraries to do a call directly, because the gateway API exposes functionality for you to talk back to clients.
Okay.
I haven't investigated that directly, but yeah.
So the
Yes.
connection from the gateway to your, if you're an EC2 instance, for example, is a WebSocket, right? So the API gateway is essentially a web proxy for WebSockets. So it will terminate the connection and then create a new WebSocket connection to your device. So
Your device connects to a edge server which handles that connection for you.
Yeah. And what is the protocol that's gone from the
WebSocket. WebSocket. Plain WebSocket, nothing special.
Is your question inside the AWS infrastructure? Is it a WebSocket to your EC2 instance, or is
Oh, no, from that point, it is pretty much whatever you want. You can have it do HTTP calls. You can have it do via a Lambda function invoke, do whatever you want. I don't think it supports having WebSockets, but your EC2 instance can also connect to the gateway using WebSockets and maintain its own stream open. So that is possible.
Cool.
Sweet.
Does anyone want to